So this is a meeting of the Terrestrial Ecosystems Community of Practice, but we have designed this webinar to be in conjunction with the data management team from IARPC as well, and they've helped us to come up with some questions and have talked with us about our speakers. So we're very appreciative to have that team part of this as well. So what we have today is going to be a collection of different archive centers that archive Arctic data, and kind of just hearing from them a little bit about the types of data they archive and what's important to them as they're archiving this data. And then we'll have a period of discussion for about half the time, where we'll just kind of, we have a few questions that we can use to seed the discussion, and then we can also do questions from the group as well. So we're going to just go in order of how this was posted on the IARPC website when we set up the agenda. So we're going to start off with Joan Damerow from ESS-DIVE, and I'm just going to let each presenter introduce themselves. You'll have about 5 minutes, and then I'll come on and tell you you've got about a minute or so left, and just to give you time. And
Liz,
thank you all.
Before we jump in, can we ask all the participants to just give an introduction in the chat, your name,
Yes.
affiliation, and interests, just a quick introduction so we can get to know participants. We won't do a around the room intros, but in the chat would be great.
Yeah, that would be good. Thank you, Elizabeth, for that. And I should say my co-leads for the Terrestrial team are Elizabeth Powers and Daryl Yang, who I believe are also on the call. So thanks everybody for being here. All right, go take it away, Joan. I don't hear you.
Sorry about that.
There you are.
I had to unmute. Yeah, thanks for inviting me here today. I'm really happy to be here. And so I am Joan Damerow. I'm a research scientist at Lawrence Berkeley National Lab and the community engagement lead for the ESS-DIVE data repository, which I'll introduce you to today. So ESS-DIVE is the DOE data repository for the Environmental Systems Science program. And our mission is to provide long-term preservation, broad accessibility, and improved usability of environmental system science data. So this program includes a variety of studies in different systems like watershed sciences and terrestrial ecology, coastal ecology, and urban ecosystems. So we're a fairly new repository that was launched in April of 2018. But we are growing steadily, and we have about 854 public data sets up to this morning. So we support publication for projects that are funded by this environmental system science program that I mentioned. So we have really diverse data spanning a variety of different observational, experimental, and modeling activities in earth and environmental sciences. And so we do have a fair number of Arctic data sets. Doing a simple keyword search in our data search portal brings up about 96 data sets, and a good portion of these come from a particular project, the Angie Arctic project. This is the next generation ecosystem experiments that some of you may know about. It's a multi-phase project that started in 2012 and will be winding down over the next year. And their goal was to improve predictive understanding of carbon-rich Arctic system processes and feedbacks to climate. And so they are moving their project data to ESS-DIVE. So we currently have about 58 data sets from them, and that number will be growing over the next year. So the types of data produced across environmental system science projects span numerous disciplines and scales, which is really a hallmark of this kind of research. So the graph on the right provides some examples of data types and variations in temporal and spatial scale that they represent. And what we do at ESS-DIVE is provide a central place to archive this data. So our goal is to archive this interdisciplinary environmental research data that may span multiple fields of work and data types. And we support the end-to-end data management lifecycle. And this includes multiple ways to upload data and submit data sets through a web portal, or we have an API as well to submit data sets. We have an iterative review and publication process for our data sets, and generally follow robust data preservation methods, including assigning DOIs to each data set, versioning, and data auditing. We enable search and data discovery across multiple other platforms, including Data One and Google Dataset Search. The ESS-DIVE API also enables programmatic search and download of data, and this allows other repositories to query our data in a standard way and publish and link out to our data. And we also now enable link outs to external repositories where ESS projects may already have data. So we do this through standard metadata linking to external sources. And when you are looking at a dataset landing page on ESS-DIVE, you can view all of ESS-DIVE standard dataset metadata and see some clear links to external sources where those may exist. And so this allows projects to store data that wherever it makes the most sense for their project, while also making it searchable on ESS-DIVE, along with all of the other environmental system science projects that are funded by DOE. We will actually be holding a 2-day open data workshop in a couple of weeks on November 15th and 16th. And this will include presentations on our features and our vision for the future. We'll have a number of community project data management presentations. We'll have a couple of discussion sessions, particularly one on linking related data across DOE's biological and environmental research data systems and approaches for that. And we'll be discussing scientific use cases for linking related interdisciplinary data. So if you happen to be part of a DOE ESS project, you can register using this link and QR code. And this is actually an annual workshop that we hold, and it's a really nice way where we can provide tutorials and an opportunity for our users to have discussions with other projects, and also give us feedback on how things are going with our repository and the features that they need.
You have about a minute left or so.
Yeah, so I'm pretty much done, and just wanted to conclude with some with this slide showing different ways to connect with our team.
Joan, that was a really great presentation, lots of good information in it. And we're going to move right on to Oak Ridge National Labs Distributed Active Archive Center, the DAAC there, and let them take it away. Thanks.
Great. Thanks, Liz, and thanks for the invitation. Hi, everyone. This is Yaxing. I'm the lead scientist from the Oak Ridge National Laboratory Distributed Active Archive Center, ORNL-DAAC, for Biogeochemical Dynamics. And the ORNL-DAAC is one of NASA's Earth Observing System Data and Information System, EOS-DIS data centers. I'm really glad to be here having a discussion with you about Arctic and Boreal ecosystem data archival and access, together with my colleagues, Debjani Singh, our data ingest lead, and also Michelle Thornton, our airborne data lead. So to set up the context, I'd like to first give a very brief introduction to NASA Earth data. NASA Earth data makes NASA free and open Earth science data interactive, interoperable, and accessible for research and social societal benefits. NASA Earth data holdings are large and diverse. NASA is really well known for its large satellite missions, represented by the image on the upper right corner of this slide, the Earth fleet. But NASA also has an active and diverse airborne science program, collecting data from an array of airborne instruments. And also just as active and diverse is all the field research supporting and enhancing the airborne and orbital missions. And all of these diverse data are archived and distributed through the NASA DAACs. So what are the DAACs? Distributed Active Archive Centers. There are currently 12 DAACs distributed across the United States, as shown on this map, with each DAAC focusing on a different science discipline. And the ORNL-DAAC is located in East Tennessee and focuses on biogeochemical dynamics and serves as the primary data repository for data derived from NASA's Terrestrial Ecology Program and Carbon Cycle Science and Ecosystems focus area. And the ORNL-DAAC increases the value of scientific data products by performing quality check, standardizing data formats, developing data user guides, creating standard metadata records, and also promote data use through tools and services, and also training and user support. So the ORNL-DAAC has published a large variety of data products since it was established back in 1994. And as of today, there are close to 1,800 active datasets available from the ORNL-DAAC, covering multiple science themes, including Arctic ecosystem, carbon cycle, vegetation, and etc. So I'd like to highlight data from the above project. The Arctic Boreal Vulnerability Experiment, or ABOVE, is a major field campaign funded by NASA's Terrestrial Ecology Program, and the ORNL-DAAC is the primary repository for ABOVE data. And the above data products are highly diverse, ranging from field experiments to airborne measurements, including the average Angie hyperspectral imageries as highlighted in the center image on this slide. And also products derived from satellite observations and modeling products. So as of today, there have been 180 above datasets in multiple science themes archived at the ORNL-DAAC. And I'd like to mention that's not all the above datasets, because there are some other above datasets available from other NASA EOS DAACs, which I will talk a little bit about later. So as I mentioned, the ORNL-DAAC is not the only data repository for above, nor for NASA's Arctic and Boreal ecosystem data. There is a lot of data archived through other DAACs. NASA EOS is going through a cloud evolution in recent years. The DAACs, including the ORNL-DAAC, are migrating data holdings and tools and services from on-prem onto AWS cloud. There are many benefits of this cloud evolution. It helps with the integration of different NASA DAACs, I mentioned 12 previously, into a holistic data system, and make it easier for users to find, access, and use NASA Earth data. It also enables cloud-based in-place data analysis at scales and flexibilities that cannot be easily achieved on-prem. And
You
this
have about
diagram,
a minute left,
okay.
Yaxing.
Sure. So this diagram illustrates an idea of how different NASA Arctic and Boreal ecosystem data archived at different DAACs can be integrated together. So this is my last slide. I want to highlight the tools and services to support data search, visualization, and access. There are on-prem tools and services that the ORNL-DAAC developed shown on the left side of the slide, and also the emerging NASA Earth Data Enterprise tools and service shows on the right side. So I want to mention that the NASA Earth Data Enterprise tools and services, including the Earth Data Search, Earth Data Harmony, OpenDAB, and GIS services, provide consistent mechanisms to search, visualize, and access data from different DAACs. And it's worth mentioning that we leveraged the Earth Data Search and created a data portal for above, from which users can find and access all above data, including those from the ORNL-DAAC and other DAACs. And that's it from me.
Thanks so much, Yaxing, and the ORNL-DAAC team. We appreciate you coming and joining our panel. Next up, we're going to have Matthew Jones and Angie Garcia from the NSF Arctic Data Center.
Hi, everybody. I'm Matt Jones. I'm from the Arctic Data Center at UC Santa Barbara. And unfortunately, today Angie couldn't make it, so Angie's not with me today, but I'll be presenting about our work at the Arctic Data Center. The Arctic Data Center is the primary repository for the Arctic program at the National Science Foundation. And it's an open access repository providing access to all data coming out of the research projects that are funded by NSF Arctic programs. It's an open access repository with basically data spanning the global Arctic. While we primarily focus on research coming out of the National Science Foundation, we'll really support any researcher working in the Arctic to deposit data across a wide variety of disciplines. We currently hold a little over 7,000 data sets that mostly are in the long tail. The vast majority of the data sets are say less than a gigabyte in size, but increasingly we're seeing increasing numbers of large data sets from field researchers and others using unmanned drones and other types of technologies to generate much larger data sets. The data sets that we hold span a really wide variety of disciplines, a lot of disciplines in the natural sciences, including oceanography, atmospheric science, soil science, things like that, but also in the social sciences, like anthropology and paleontology and economics and archaeology are represented. And so we are truly an interdisciplinary repository and have to support the multiple different data standards from those many different disciplines. The collection has been growing fairly linearly over time. We took over operations in 2016 after they'd been operated a number of years. But before that, I think the original facility was started in 2009. And so it's currently at about 104 terabytes, growing at about 11 terabytes a year. You can see at the bottom red line in this graph that the vast majority of our data sets are close to the 0 mark, but there's a handful of data sets that are up in the 1 to a few terabyte range. And so those few hundred data sets represent the vast majority of the volume of our collection, whereas most of those 7,000 data sets that we hold are relatively modest in size. These larger data sets that we're starting to collect are becoming more of an issue for us and becoming sort of a major part of our management strategy. We've been building new facilities and structures for handling large data sets, including the ability to visualize them. One of the things that we found is that many researchers can't look at a 15 terabyte data set and really be able to explore it in a way to figure out what it is, what parts of that they need to access. And so through partnerships like with the Permafrost Discovery Gateway, we've been building visualization tools. This one is showing a distribution of sub-meter permafrost ice wedges at global pan-Arctic scales. And so people can sort of interactively explore these really large geospatial data sets. Supporting access to these, we have a number of different ways for people to get access to data and to transfer it to us through traditional web search and download tools. We use the same tool chain that ESS-DIVE was presenting on. We have a REST API for accessing data, open services like the OGC's web mapping tile service, the Globus endpoints. And in the future, we're planning on expanding into new areas like stat catalogs and OpenDAP and ERDAP for these larger data sets. We also have an automated metadata and data quality engine called Metadig. This is run on all data sets that come in and help provide an automated set of quality checks for data that's being brought into the repository. And then we also have an iterative set of human reviews that improve the quality of submissions before they're published and released with a DOI. Overall, we provide 6 major areas of features: the data archive and discovery portal and those tools and infrastructure. But we also have support services, training outreach, and data rescue services. One of the things I'd like to highlight for a minute is just our focus, relatively recent focus on ethical data practices in our metadata submission. Working in the Arctic, there's a lot of groups that are working with sensitive or semi-sensitive data. And so we've started collecting structured information about the ways in which projects conform to community standards like the CARE principles. And we specifically require that every project document the ways in which the research methods they used were ethical, and asking them to be explicit about any kinds of IRB reviews they need, consent waivers, the way in which they interact with Indigenous communities, and other types of issues around data ethics. And we provide a fairly detailed set of guidance about questions that each of the different research disciplines should be thinking about when documenting ethical research practices for their data submissions. And so we have different questions for marine sciences than we do, for example, for archaeology. And this is all available through the Arctic Data Center website. And then the last thing I wanted to emphasize was the capacity building role that we play in the community. We found over the years that there's a real set of value in us being able to interact with our community of researchers and help with data management and data science skills in the community. So we've been teaching a set of 3 different introductory short courses for data science. One's in fundamentals of both qualitative and quantitative data management.
You have about a minute left too.
Thanks, my left side. The second one on reproducible approaches to Arctic research using R. And then the third one on using Python for scalable and computationally large research, mainly on how to parallelize and work at larger scales with research data. So those 3 courses are all open for researchers in the Arctic community to take, and we offer them once a year. So with that, I'll leave you with our slide and looking forward to the discussion. Thanks.
Thanks, Matt. That was really interesting. I appreciated your talk. We'll move right along to the Environmental Data Initiative with Paul and Colin. We don't hear you yet. Make sure you're unmuted. We see your screen though, Colin.
Yeah.
There you are. Okay.
Oh, can you hear me now?
Yep, we hear you.
Okay, thanks so much. Yeah, my mute button got trapped somewhere once I started sharing my screen. So hello, everyone. All right, you can see my title slide?
We see your title slide and we hear you. Yeah. Now we see the project overview.
Okay, awesome. Fantastic. Hello, everyone. Thanks for the opportunity to speak at today's event. I'm Colin Smith with the Environmental Data Initiative, and am part of a team consisting of highly motivated and experienced data practitioners, software developers, and research scientists. It is the mission of the Environmental Data Initiative to preserve environmental data for open and reproducible science, to promote synthesis across space and time, and to aid in the assessment of environmental change and its consequences. We offer services and technical support for the curation and accessibility of high quality environmental and ecological data and metadata. And we collaborate with information management leaders to promote best practices throughout the broader research community. The EDI repository satisfies DataCite standards for accurate identification of digital resources and is now Core Trust Seal certified. Our curation team participates in the development of data standards and adopts their recommendations. We have been active in the FAIR, Trust, and CARE initiatives. The repository strikes a balance between general purpose and specialized repositories. We prioritize high quality data and metadata without enforcing strict rules on data structure and formatting. This approach allows authors to present their data in the way that works best for them and their community. The repository contains more than 7,000 diverse data packages with over 19,000 revisions spanning temporal scales from days to decades, and are primarily originating from within the US. I should mention that we are not strictly focused on the Arctic region, and most of the Arctic data sets that we have come from a few LTER sites that are publishing data with us. Over 99% of the data packages in our repository are openly accessible and downloadable. So it is the upload process that ensures the data and metadata quality by verifying the metadata accuracy. This process includes metadata upload, schema validation, the data to metadata checks, and generation of a quality report. Any critical issues listed in the report must be resolved before publication. Data package landing pages provide rich and accurate descriptions of the data objects, including context, purpose, collection methods, spatial and temporal coverage, and details about measurement variables and much more. Also in the landing pages are exploration tools, which offer quick access to the data, thereby deepening understanding beyond the metadata alone. So the DEX service that we have is a web browser-based tool that offers summary information, subsetting, and plotting features. And also within the landing page are links to download scripts to allow ingestion of data in common programming languages such as R, Python, MATLAB, so forth. Data packages and their contents can be downloaded manually through the EDI data portal through a simple point and click operation, but also programmatically via our REST API, which provides a basis for reproducible workflows. We have an R package, EDI utils, that replicates the API functionality in the R language for users that prefer that language. Creating and maintaining personalized data catalogs is straightforward. Using the REST API to query and parse data package metadata, you can create a searchable index on your project's website, enhancing branding and discovery options. We create analysis-ready data products through the process of thematic data harmonization, which helps to improve data package interoperability within our repository and with collaborating repositories. We are committed to continuously improving and expanding our repository and services to accelerate research in ecology, and we encourage you to share your needs and ideas for new services with us. So thanks again for your time, and I'm looking forward to the discussion ahead.
Thanks so much. I appreciate that talk, and I think we're going to have some really great things to talk about in our discussion coming up. So last on our list, we have Joshua Brown with the ELOKA, the Exchange for Observations and Local Knowledge of the Arctic.
Hello, can you hear me?
Yeah, we can hear you and see your presentation.
All right, thank you. Yes, my name is Joshua Brown, and I am a postdoctoral researcher with ELOKA. I hail from the Confederated Salish and Kootenai Nation. I work primarily remotely for the University of Colorado and ELOKA. So I'll share some general information about ELOKA. Next slide, please. ELOKA was launched in 2007 and is housed at the National Snow and Ice Data Center at the University of Colorado. And it has recognized the importance of indigenous knowledge and understanding changes in the Arctic. So as you can see on the slide here, we have a lot of partners across the circumpolar Arctic region. We have partners in Alaska, Canada, Siberia, and Finland, and Canada and Greenland. Next slide, please. So these have been the key products throughout the years. We primarily have two types of products. We have what is known as an atlas, and within these atlas is a lot of different data sets, information about particular communities. So it ranges from information about flora and fauna to cultural information to historical information. There's a lot of maps integrated into this, and there will be lots of data about particular communities or places, and all of it is typically bilingual. So it's in English and in whatever the local language people prefer. So for example, Yupik, Athabaskan, Sami, and Evenki, and Greenlandic. Next slide, please. So ELOKA is very much about connecting folks and curating data sets from other partners. So over the years, different entities, primarily from indigenous communities, have partnered with ELOKA. So typically what happens is indigenous communities, they have projects in mind, and they often collect all of the data, and then ELOKA has been involved in helping to edit and upload and put that into platforms. Next slide, please. So this is an example of one of those projects, UPIC Environmental Knowledge Project. This is one of the atlases, and it can, as you can see, it contains not only maps but information about lands. It also has demographic information about UPIC folks, things that are important to them. Next slide, please. And then another a major component of ELOKA's work is with local observations on the ground. So this is primarily looking at weather, and this is one of our partners, and together ELOKA created some online platforms where local observers input their information about observations. So for example, it might include photographs of the landscape or water, snow conditions, ice conditions, things like that, photographs of animals, and then they might describe the weather. They also have air temperature, things like that. Next slide, please. So currently, ELOKA is expanding its partnerships, and what we're really focusing on is revisiting indigenous data sovereignty, and we're exploring deeper what that means to our organization and how we can uplift and amplify data sovereignty for our various partners. So we're having multiple conversations with all of our partners to explore what that means to them and what they would like us to do moving forward. And we're also helping to train folks. As you can see in this photograph, young folks are being trained in multimedia production. So they're recording an elder from the community. And so this is something that we're hoping to do, is to get more of the Atlas work into local schools. We partner with some local schools, and we're helping provide training to these folks about how they can implement or use the atlases and the observation data. Next slide, please. As I mentioned, indigenous data sovereignty is a major priority, and we continue to think about this and think about the care principles and the FAIR principles and how those impact and can be implemented on the ground in more concrete ways within our work and with our partners. Next slide, please. And I just want to conclude by saying, again, we're really about partnering with indigenous folks, indigenous communities, and we are connectors and curators. So their data is shared on our platforms, a new LEAP platform. It's an open source platform, and another system that we have created. And these have protections on them, so there's login sites for some communities. They wanted to limit access to certain types of information or data within the Atlas only to community members or other researchers. So we have those limitations on it, and we continue to explore what are the most ethical ways for us to present and share data, not only with the indigenous communities themselves, but across the globe. Thank you.
Thank you so much. I really appreciate having all of our speakers come today and talk. And maybe if our panelists want to just turn their webcams back on, and we'll just have a discussion. I think what we'll do is maybe I'll start it off with a question, but then if folks had questions about any of the different presenters, you could put something in the chat and we could ask it, or you might be able to just unmute and ask it. But I think My first question is, when we kind of thought about doing this this panel, we wanted to hear from the different places you could go to find Arctic terrestrial data. And there are so many places, which is amazing that all of these are available, but it's also can be a real challenge to for researchers to try to put it all together. And I really appreciated that in your presentations, many of you highlighted the different ways that you're starting to work on that, kind of working with Data One or having an API or having a platform available. But I just maybe wanted to get some of your impressions on your thoughts for researchers who are kind of starting on this process to find data for themselves to use. Anyone can feel free to take it away.
So I didn't talk about this during my talk, but I would highlight Data One as a nice place where I think most of the repositories that were listed here are already participating in a federation, and you can search across all of them to be able to access the data sets, and then that in turn redirects you back to the individual repositories to get access to the data and to use their other tools. So I think it's a really good sort of intermediary and can help build collections of data that span repositories and whatnot. But I focused on the Arctic Data Center, but there are currently over 55 repositories in the Data One network and growing every month.
Anybody else on our panel want to chime in on that one? I don't know, Joan, are you which other data centers that we have today? Who all is in Data One? All right, Colin, yeah, Joan. I don't know, Yaxing, does NASA put their data into Data One?
ORNL-DAAC was one of the member nodes for Data One.
Okay.
So Lisa, I just want to add that I mentioned that in my presentation, NASA Earth Data has really taken an initiative to establish a more consolidated system to integrate basically data across all NASA US data centers together to make them easily findable through what they call a common data repository. And they also have nice web user interfaces and standard APIs to support data discovery. But I think data search and this discovery across agency boundaries remain a challenge. There are many different types of users. I think different types of users from different communities, they use basically different ways to find data. But I know a lot of people, they just start from Google. That's probably the first starting point for many of the new users for NASA data or other types of agencies of data. So I think one of the efforts that NASA has made is to improve the ranking and the findability of NASA Earth science data through popular search engines like Google and also Google data search. I mean, that depends on how we curate the metadata and how we curate the dataset landing page to embed necessary metadata information and the elements to support search engines to index and find the most relevant data products.
Yeah, and I know. Yeah, go ahead.
Sorry, I just want to amplify what Yaxing said, and I think this is a really important point that if repositories do follow the guidelines for exposing this metadata to aggregators, it makes it a lot easier to build networks, both through Google Dataset Search and other tools. So the Earth Science Information Partners, or ESIP, has been developing a set of guidelines for how to represent schema.org metadata for this kind of web aggregator harvest. And we've been able to take advantage of that in Data One and be able to onboard new repositories much more easily because of that. And then you also show up in Google much more easily if you do that. So anybody who's got a repository that they want to show up in these aggregators more, encourage them to do that, and it makes it a lot easier.
Yeah, I agree with all of that. And I just wanted to add, so ESS-DIVE, like like I mentioned, we're supporting projects that are specific to the DOE's Environmental System Science program. And so we're trying to make all of the data from this program searchable in one location. And so one way that we do that is if people are publishing, if researchers are publishing data that may need to be on a specific platform, like in CBI for omics data, or ESGF for model data, we enable just having data set metadata on ESS-DIVE and then linking out to those different systems. So that's one way that we're trying to enable improved discoverability of all of this of projects across this particular program. But one thing that we are finding still an issue that we're working on across platforms is because we have this really interdisciplinary data. Currently, it often is pretty disconnected, even so we have highly related data that are part of studying an ecological system. Like the omics data will be in one place, the environmental data will be in ESS-DIVE. So we're trying to coordinate across the different data systems that our researchers are using on standard approaches to link and exchange related information about these projects. And that's we have a session in our upcoming workshop where we're discussing this with the community and gathering feedback and working on a paper together. So it's something that we are actively working on.
That sounds really neat, Joan, to kind of work on it with the community and develop a paper from it. I wanted to follow on with Joshua. You had talked a little bit about the platform that ELOKA is working on to kind of showcase the data. I wondered, would it make sense to put the type of data that ELOKA has in something like Data One, or I think this is one of the things we wanted to talk about too today was the idea of the FAIR and CARE principles. And so FAIR, for people who aren't sure, is FAIR is findable, accessible, interoperable, and reuse. And then the CARE principles are collective benefit, authority to control, responsibility, and ethics. And so kind of, making data sets more accessible, but then also still bringing it back to making sure that these choices are made in a responsible and ethical way for everyone. So I wondered, Joshua, if you had some thoughts on that too.
I think it would make sense, but our partners really drive the conversation and the decisions within our organization about how and where data should be stored or presented. They just recently in August, we met with some of our partners in Alaska, many of our partners, and they brought up concerns that they have, even about some of the which might seem benign, it seemed benign to me, data about weather observations and things like that. And in those observations is information about hunting, and oftentimes they might share photographs about hunting. And one of their concern was that they're afraid or hesitant to share this kind of data more broadly because they're afraid that others might utilize it to attack or damage the community, their ways of living and being, because they see some megafauna that many folks might take issue with. So on one hand, I can say, yes, it does make sense for it to be in this other system, but there are some other concerns about who has access to this data. And so they're really driving that conversation for us. And so we're moving at the speed that our partners are most comfortable with.
Yeah, I think that makes a lot of sense. And I could even see, this has come up in other geographic areas around the world too. For instance, like publishing location, like animal tracking data on elephants or something, because then if you publish it, then somebody can go and find the elephants. So it's like, how do you make sure that you're making data available, but also being sensitive to the needs of the communities?
Yeah, just to add to that, I will also say, they've expressed much interest in sharing data about weather and climate changes and how that's impacting their communities. Because before I started this postdoc, I will admit I didn't know that much about some of the Arctic regions. I'm not from there. And it's incredible how how much negative impacts they're experiencing now. So they're wanting to share that, and they're like, how do we make the world more aware of the negative impacts on our community? So that's one piece that they would really like to share, but maybe some of this other data they're not interested in sharing that as widely.
Yeah. Thanks. I think it's, I'm glad we could kind of bring some of these, I don't know, traditional knowledge data sets to our conversation to kind of help our community to think about it more and think about how we can utilize these data and how to make sure that we're doing it in a responsible way. I'm going to move us on to another question, which we had on our list, which are, what are some new insights on data access across some of these different centers and data processing? So cloud access or compute, some of the kind of new cloud capabilities. I know Yaxing talked a little bit about that, and I think maybe others have thought about that too, in terms of making data accessible and findable and usable on cloud systems. Do you guys have some thoughts on that? Because that's one way that it might be easier to bring data sets together from multiple places. You don't have to download them if you can just kind of load them into your cloud processing location. Any thoughts from our panelists?
So I'll just sort of play devil's advocate for a minute. I think it's a great idea. So I'll start off with that and say, I think that for some data sets, especially the really large ones, there's no choice but to try to, put the data and the computing resources in the same place and access them. And so the use cases that Yaxing brought up, I think are great. But there's also a huge collection of long tail data for which those kinds of data processing resources are not necessary. And there's a pretty large sort of kind of learning curve associated with learning how to use cloud computing. So we interact with researchers from many different disciplines across the Arctic, and we teach our short courses on data science. And I can say that the vast majority of them are not currently ready to basically fully embrace cloud computing as their core way of doing computing. And so I think we need to continue to support access, especially to long tail data, by the broad suite of researchers that we have. And for many of them, download and analyze locally is still the sort of standard way of doing things. That said, I think for larger data sets and for people that are doing, for example, really, global scale modeling or things like that, then I think we really should be trying to facilitate that kind of access. But it's not like a full wholesale swap to the cloud. It's sort of supporting both modalities.
So Liz, I just want to add on top of what I mentioned in the presentation, and also Matt just mentioned, so NASA has really taken a big initiative on migrating data and services to the Amazon AWS cloud. And there are a lot of benefits of doing that. And there are also a lot of challenges with that. I mean, it's definitely a benefit, I think, from the DAACs, the data centers perspective. Like I mentioned, it's only because of the cloud migration effort that the interconnection and integration of the data and tools and services across those different NASA US DAACs could happen easily. Previously, when we tried to integrate another DAAC's data into our on-prem tools, we had to either make a local copy or invoke some remote services from other DAACs, which caused a lot of performance issue. And now because of the data are co-located together, we can do a lot of things to better support data visualization and data access. That, on the other hand, will help users. But making sure that end users can really benefit from doing analysis within the cloud still needs a long way to go. There are a lot of users, especially like Matt mentioned, who do not necessarily work directly with large or huge data, and they have their existing on-prem data analysis workflows. There's some learning curve and barrier on migrating their existing workflows onto the cloud. And that's one of actually the investments that NASA, including the ORNL-DAAC, has been doing to really provide that kind of training and user support to encourage users to take advantage of the cloud computing and also lower the barrier of getting users into the cloud computing environment.
I'm glad you brought up training. And I think it was Colin, you talked a little bit about maybe some capacity building work that was it you guys who talked, one of you guys talked a little bit about capacity building, I think. And that seems like an important part of data management too, or thinking about how do we build up these skills for new researchers to, one, just do data management and bring and use data that's in the cloud, but then also just, finding it and figuring out how to work with it and in different and new ways.
Yeah, we do a fair amount of capacity building, and that's part of our core mission. But also Matt had mentioned some of their resources, and Matt, I want to hear more about those here in just a second. But so we would hold workshops, data management training workshops early on, and then we began trying to scale that knowledge out to the community by taking those lessons learned and those processes and bringing those to our website and kind of having, a sort of user manual, if you will, for information related tasks around data publishing. And so we're still building that up. And a lot of our involvement with the community in these regards is just one-on-one inquiries that come in, specific use cases that users have. We always encourage people to reach out to us if they have any sort of data management related issue, or they're trying to achieve something and they're not exactly sure how to do it. We can offer some perspective and advice based on kind of what the community recommends, or at least get them pointed into the right direction. So those are some of the sorts of capacity building efforts that we have at the Environmental Data Initiative. I don't know, Matt, did you want to speak a little bit about your efforts?
No, I just put a link into the course that I referenced before, and we'll be opening that up for people to apply. Unfortunately, we have limited space, and so we will frequently not be able to accept everybody that comes in, but we do try to reach out and then prioritize people that have come in multiple years. The materials are also online and available for anybody to go to at your own pace. So.
Well, I've really appreciated all of the discussion. We're coming up to the top of the hour, so I wanted to ask if anyone had any burning thoughts or questions, either from our panelists or from anybody in the audience, if there were any kind of final comments you wanted to make first before we start to kind of close things out. Also, if there are any announcements for the Terrestrial Ecosystems group, if you want to just put them in the chat. I can just say we're not going to have a meeting in December for our team, and we'll pick back up in January, December. Right? We know many people are part of the American Geophysical Union meeting, and we don't want to compete with that. So, any last thoughts from anybody? Our last few minutes.
Yeah, I was going to share something quickly.
Yeah.
I just want to advocate for the idea of including, sounds like some of these data sets people mentioned are quite large, but I still want to advocate for including more metadata. I've been going through a lot of ELOKA's own data sets, and there's clearly some things that seem to be would enrich what we have, and that would include more contextualized data about the data. I just think that's very important.
Yeah, and I think that's something that all of the archive centers often have to work with data providers to do, is to make sure that as they're providing data that they have all the metadata that's needed, and to make sure that then others are able to use it and that it's reusable. And I think that's really true, Joshua, and we can always kind of make sure we're kind of meeting that a little bit more and kind of training people up and how to even provide data, not just use it, but how to even provide it to data centers, I think can be really important. All right, well, we're reaching the end of the hour, and I just want to really thank all of our panelists for joining us. I think we've had some great discussion, and I really appreciated everything that you were able to talk about and bring to the table. And I hope it helps our terrestrial ecosystems community to think about all the data sets that we have available and where we can find them, and how we can even incorporate some of our the indigenous knowledge that's available, and make sure we're doing that in a way that is respectful and helpful. And so I appreciate everyone being here today, and I hope to see many of you again in our next meeting in January.
Thank you, everyone.
Thanks a lot.
Thank you.
Bye.
Thanks, Liz. Thanks,
ya.
everyone.
Thank you. Bye.